Hello, welcome to COMPUTEX. I'm Raj Hazra, and today I'm excited to talk to you about why memory is at the heart of AI innovation. But first, a few things we have to get over. The safe harbor statement. I hope you take a few seconds to read this, and then we'll get on with the topic at hand. The first thing I want to talk about is the pervasive growth of artificial intelligence fueled by the tremendous amount of data that exists in the world today and is getting added on a daily basis. In a short matter of 4 years, 90% of enterprise applications will embed some form of AI capabilities in those applications, whether it's in conversational interfaces, whether it's in how they deal with multiple sources of data to train and make predictions, versus simply being told to model and simulate, whether it's in the applications they enable, from smart manufacturing to smart ways of dealing with customer relationships and supply chains. Artificial intelligence is in everything that these applications do. Along with that tremendous growth of application capability using AI, in that same time frame, the number of organizations that will operationalize AI systems, take those capabilities from test and dev, or trials or early POCs, and make it the way those businesses operate, is going to be tremendous growth from what we see today or have seen in recent years as experimentation to how the lifeblood of those organizations are run. Whether, again, it's in how they create products and services, to how they maintain their own supply chains and manufacturing, or even how they look at their talent pool and acquire new talent, grow their talent base. All of those aspects of the business is going to be touched by the power of AI. So with so much growth and so much potential for AI, the big thing we have to think about is how do we continue to enable it? And this is, as practitioners of the craft, is what we see as our challenge, our calling to deliver on. What is that challenge? The challenge is essentially the exponential growth of the need for infrastructure to keep up with the promise of what AI has to deliver. On the left of this slide, you will see a chart that shows the number of parameters in a model to deliver a useful outcome, to deliver a model that can deliver useful outcomes across a broad spectrum of uses. I'll give you one example, and that's on the slide at the top. GPT-3 is about 175 billion parameter model. It's an open source model well used today for natural language processing, learning natural languages. And it's widely accepted as one of the best known ways of doing things. But in the short span of 2 years, we're not talking about 1.6 trillion parameter models. 1.6 trillion parameter models in 2021 using things like mixture of experts and sparse transformers. The promise of AI is that AI gets more accurate, gets more effective, and gets more pervasive as a result. The challenge it poses is this tremendous complexity of compute, which you see on the right-hand slide, to deliver the capability to make that AI, to make those more and more intensive models come to life. But much has been said about the compute portion, and it's true. We've gone from teraflops to petaflops to exaflops in a short matter of years, truly an exponential growth. But what is not as often talked about is compute, or computing is starved without equivalent or sometimes even faster innovations in memory, particularly in memory capacity to store the data that these models, that these algorithms use, and most importantly, the performance that is required to continue to feed these increasingly data hungry, increasingly powerful compute engines. Simply put, just working on making compute more performant and energy efficiency is necessary, but not sufficient to solve the problem. We at Micron focus on ensuring that AI's full promise is delivered through innovations in memory and storage, working in partnership with those that build compute. Delivering this balanced capability between memory and storage and compute requires us to look at that growth of AI complexity in two dimensions. One is what we call the scale up dimension. What do we mean by scale up? Scale up simply means providing more compute, memory, and storage for a single instance of what you want to use the training for. It could be a single node in a server. It could be a single shared memory cluster. But as powerful as they can get with advances in memory and storage, bandwidth, capacity, and compute performance, they're still limited by what you can physically, technically, and even economically can compute or make available on a single node. The other dimension, while each of these units of AI become more powerful, is to connect those units and scale out. And this is where hyperscale is really, really a tremendous move forward. Being able to connect in a distributed sense, in a distributed way, these elements of AI generating, instances is the holy grail of achieving essentially unlimited scale. You're no longer captive to what a single instance can do. It's the collection, the power of the collection that enables you to scale out and tackle problems well beyond even the 1.6 trillion parameter models that I was talking about. And when we add on what we can do, not just in the data center, but take it out to the edge, to the billions of computing instances armed with memory and storage that can effectively work together to solve some of these problems, the possibilities are endless. When we talk about memory innovations for AI, the first thing we have to go back to is recognize what a tremendous change, just in a matter of few years, the computing platform for AI has undergone when we talk about memory and storage. Just a few years ago, I remember it used to be a CPU, direct connected DRAM, and then a hard disk, and soon thereafter came an SSD. The world is no longer that simple. The world cannot be that simple anymore because of the needs of algorithms like AI that require a much more sophisticated approach to how memory and storage is created for those kinds of workloads. As you see on the slide, the near memory that used to be just direct attached is now a combination of in-package memory, something like high bandwidth memory, as well as increasingly more powerful direct attached memory, DDR4, DDR5. But there is a new instance of memory called far memory. The world would love to have all of its memory as near memory, but there are technical challenges to doing that and economical challenges to doing that as well. With the advent of platform interconnects like the Compute Express link, which you see here on the second instance of far memory, what you will see is the ability to add memory, both capacity and memory bandwidth, without being constrained to what you can directly attach, and creating new memory tiers, the CXL attached memory tier, and perhaps the further in that far memory of storage class memory. This is before you go into storage and potentially use storage with software innovations as memory as well. So what you see here is for algorithms and workloads like artificial intelligence that are both compute and memory intensive, fundamentally they're data intensive algorithms. You need to create a hierarchy where two things happen. You need to have a memory hierarchy, and you need to converge at some point the memory and storage hierarchies so data seamlessly flows from archival storage, where it may have been collected and kept for processing, all the way into the hot little compute engines that are going to create those insights. All in all, it isn't quite like it used to be, but it can't be what it used to be simply because we have new things to work on, like artificial intelligence, which produce things and benefits that we've never been able to realize before. I talked about the power of then taking these kinds of innovations on a single server or a single instance of AI compute and spreading it using applying the power of distributed computing. And this is the other place where there's tremendous innovation possibilities in how these system architectures are created using the power of pooling, disaggregating memory, storage, and compute, as you see on this slide, no longer having every instance have compute storage memory, but distributing these resources and building them, composing them for the exact size of the workload, for the exact point of time, at the exact point of time, for the amount of time you need it to execute the workload in a hyperscale infrastructure. So this provides the ability to have exactly the right amount of resources in memory and compute. For instance, to have a balanced memory compute engine for a certain amount of training for a particular algorithm in AI. It allows for the ability for multiple models to be running at the same time, and therefore bring essentially that unlimited scale with high efficiency to solving even larger problems for AI with innovations in system architecture, as you see here, including hardware and software. The possibilities are truly endless for where these system architecture innovations can go when memory and storage is capable of being disaggregated, pooled, and used differently than we've ever used them before. And that is our focus at Micron. At Micron, we look at the possibilities of new kinds of system architectures, new computing paradigms that we can enable by unleashing what memory and storage can do when we go away, when we evolve from the old model of memory and storage attached to compute to memory and storage distributed and being assembled and synthesized for the purpose at hand with the requisite amount of compute. All in all, it's a completely new world of possibilities, and we're excited to be innovating at all scales, at all levels of memory and storage technologies to make this future come closer, happen not days, not years, but today. If you look at why our excitement is so high, it's not just because of the possibilities, but it's because of our own belief in what we can do. As demonstrated on this slide, we have a tremendously capable, broad, comprehensive portfolio that we can build on to deliver the vision that I just talked about on the previous slide. High bandwidth memory, direct attached memory, high performance graphics memory for workloads that require specific performance and capabilities, and now CXL attached memory that we will talk about more in the days to come. Matching that memory portfolio is our storage innovation and the portfolio that has resulted from it, from high performance SSDs on NVMe to very workload focused hard disk replacement SATA based SSDs built on our NAND technologies. All in all, this is an arsenal that continues to get better as we bring these capabilities from our process and nodal technologies to design and even to systems and software that we take forward to build out these capabilities of the future. At Micron, nothing excites us more than innovating both for the customer and with our ecosystem. We are committed to being customer focused, solving the problems that they need solved within the constraints that they need the solutions in. We are committed to being innovative, to drive relentlessly the pace of innovation, take on challenges, and solve those challenges with commitment, with creativity, and with passion and perseverance. And we are committed to being collaborative. in order to bring the best of the ecosystem's capabilities, our partners, our suppliers, and our customers even, into building these solutions for tomorrow. It is our mission, therefore, and our commitment that we will continue to do so and continue to be at the heart of AI innovation. Thank you.